Hello, everyone, and welcome to my talk, Self-Healing GitOps, Continuous Secure GitOps using Flux, Helm, and OPA. My name is Moolchandani. I'm co-founder, CISO, and CTO at Accurics. My favorite attack technique is waterhole attack, and I love cybersecurity and mechanical keyboards, especially Holy Panda switches and SA keycaps. Let's take a look into the agenda for today's talk. We're going to see how containers and Kubernetes systems are built, especially using GitOps pipelines. We're going to also talk about what is policy as code and how it can be used for securing your Kubernetes clusters, especially when you're using GitOps pipelines. And then how does policy as code help secure the overall ecosystem when it comes to Kubernetes, GitOps, and many other processes associated with it. And we're going to also see a demo of how we'll be using policy as code and an open source project called Terascan to secure a GitOps pipeline built on Flux and on GitLab. So let's get started. So how containers are built today? Let's take a look when we use GitOps, how exactly the process looks like. So of course, in your local development environment, any developer who writes application code ends up checking in the code into some sort of source code management tool. It could be any kind of Git-based repository, GitHub, Bitbucket, GitLab, and many others. So once the source code is checked into the Git repository, now it's time for that source code to get compiled or get packaged if it is a language which doesn't require compilation into a container image, basically to be deployed on a Kubernetes cluster. This process is also called as build process. So in this build process, the end result is a container image, which lives either in a container registry or it can live in any other storage location. Once the container image is ready, this container image needs to get deployed. And for this deployment, what is required is infrastructure as code. So you would require to write various different choices are available for your infrastructure as code. It could be Helm, Customize, YAML, and many other different choices that you have. Once you've written your infrastructure as code, this code also needs to be living in your Git repositories. And once that happens, that's where your GitOps tools come into the play. The GitOps tools, the way they work is they are part of the Kubernetes cluster, and they actually sync your cluster state with the infrastructure as code that you have provided in your Git repositories. Essentially, every infrastructure as code repository can be synced with your cluster state by using a GitOps tool. We're going to take a look into a GitOps tool today called as Flux. It's a very good open source project, and it allows you to sync your clusters with infrastructure as code. And we're going to see the demo for that as well. Let's take a quick look into how Flux looks like. So this is the Flux project. This project, we can quickly see some of the instructions, of course, but let's take a look into a high-level diagram, how Flux works. So Flux can be deployed on a cluster within its own namespace, and then it can be asked to be syncing with any given registry or even any given repository located in any kind of Git-based source code management system. Once the developer commits into the repository, code like Helm Charts, Customize, YAML files, those files are then synced with the state of the cluster by Flux automatically. So essentially, the developers or the DevOps teams do not necessarily have to specifically do kubectl apply on all these different infrastructure as code files that are being checked and which are being maintained. This is also going to be the structure for our demo today. We're going to be using a GKE cluster with Flux installed on it, and we're going to be syncing it with one of the repositories that we're going to be writing on GitLab. Exciting? So that's how your GitOps pipelines and GitOps methodology works. So how do we make sure that everything that is being synced into your clusters is secure or at least has been validated from security point of view against certain policies. That's where policy as code comes in. Policy as code, what is that? It's basically also a strategy as well as technology. Policy as code allows you to codify your security policies and store them as source code. You can version control them as well. It allows you to consistently do the enforcement of security policies throughout the life cycle, from development, pre-deployment, deployment to operations. It's typically used in automated workflows because it is a low effort enforcement. And it also is a very good mechanism to do security testing on your GitOps pipeline. Some examples. If you want to ensure your secrets are not used in environment variables, you can include such kind of checks using policy as code within your GitOps pipeline itself. If you want to limit privileged containers from becoming super users or from super capabilities, you can achieve that goal as well, writing policies and embedding them into your lifecycle within GitOps. So how do we achieve that? We're going to take a look into a framework called as OPA, Open Policy Agent, which is going to be allowing us to do policy as code seamlessly. And we're going to be using an open source project called Terascan, which uses OPA behind the scene to achieve this. Terascan is a project from Accurics, has got 500 built-in policies. It's open, extensible, and it's based on OPA. Let's take a quick look into Terascan, how it looks like. So Terascan basically comes with a lot of different features and capabilities. And it also comes with a lot of different integrations with various different tool chains, CI/CD pipelines, as well as GitOps pipelines. It helps you identify security misconfigurations as well as policy violations within various different types of infrastructure as code, including but not limited to Terraform, Helm, Customize, YAML, and few others. With this architecture, Terascan also comes with the flexibility of being integrated in any kind of source code management tool, as well as any kind of pipeline. And we're going to take a look into that. So let's also go ahead and understand how this whole policy as code with OPA can help us secure our GitOps pipeline. In order for us to implement policy as code for a given Kubernetes and GitOps-based environment, we have opportunities available to do that at several different stages. So we could do this at the time of local code development, when the code is being developed, say using Terascan CLI. We can also do it at the source code management tool layer when the code is actually being checked into your Git repository. Or we can do it at the build layer when the build processes are being triggered. Or we can do it at the sync layer when the code is about to get synced and the cluster state is also about to get synced with the ISC. And that's where your GitOps pipelines come in. So today, we're going to take a look into that. So symbolically, you can see on the screen that Terascan can be used at various different stages. We're going to take a look into, specifically at the stage 6 and 7, how Terascan using OPA can be used for enforcing policies on your GitOps pipeline. So in the demo, we're going to see we're going to be using a GKE cluster with Flux installed on it. We're going to be seeing a pipeline built on GitLab, and we're going to see some infrastructure as code to deploy some applications on the cluster using Flux as well as GitLab. Ready? Let's get into it. So what you're seeing on the screen is basically a very simple namespace file. It's a file which creates a namespace, a kind on a cluster called as demo flux2. This is what we had used to create a namespace on a GKE cluster. And this is where we have installed Flux. So I'm going to show you a GKE cluster with Flux installed on it. And what we're going to do is we have already gone ahead and configured Flux to sync with the repository called SAST integration, which is located at GitLab. So right now, what we're going to do is we are going to basically deploy a Nginx application. So Nginx is basically a web server. So this is our deployment file for it. We're going to name the app as Nginx, and we're going to do 2 replicas for it. What we will do is we will push this file into the main repository called SAST integration on GitLab. And then we are going to trigger a sync from Flux. We're going to do the trigger manually so that we can show in the demo how things work. Technically, the sync could happen automatically as well, but we're going to do the sync manually between Flux and the repository. And then we'll see that the Nginx application is going to get deployed. So let's take a look into that. So this is our deployment file. And we are going to commit this deployment file into our repository in GitLab. There we go. We pushed it. And now we are on a Cloud Shell. We're going to do a Flux Cuttle sync. Basically, we are going to be syncing it. And you can notice here that Flux is pre-integrated with the SaaS integration repository located on GitLab. And we are just allowing the Flux to sync with it. We push the application deployment YAML file, which is our infrastructure's code, and we've synced it. And now let's see the namespaces. So we can see there's a demo Flux2 namespace, of course, which is where we have deployed our application as well. Now we are going to quickly see the pods in that namespace. Here we go. And we see that the Nginx is being deployed after the sync. So the developer just made changes into the deployment YAML file or just made changes into the ISE file. And that change has now been synced with the cluster state. That means that Flux is a GitOps mechanism tool, which is automatically syncing the state with the ISE. So that's why you're able to see Nginx being deployed. Next step, what we're going to do is we are going to create another Nginx deployment file, and we're going to name it differently this time. This deployment file, what you're seeing on the screen, is called Nginx deployment2.yaml, and it is going to deploy another Nginx application, basically, but the name will be Nginx2 this time. Now, why we are doing this? The previous one, when we did the installation, we did not perform any kind of security assessment before the cluster was synced. This time around now, we're going to do a security assessment before the ISE is synced with the cluster state by Flux. Now, you would see that we will be able to detect the security issues before the cluster sync happens, but we will be checking in the code again into the main repository, which is SAST integration. And so Flux still will be able to sync up, even though there will be security issues in it. Let's take a look into that scenario, and then we're going to implement a scenario how we can prevent Flux from synchronizing ISE, which has security problems. So what you're seeing now is the GitLab CI YAML file. This is basically the pipeline configuration for GitLab. What we have done is that as the code gets checked in, we want GitLab to kick in a pipeline with the couple of stages in it. The first stage that we are calling here is a scan stage. We're going to be using Terascan for that. You can see on the screen how we have configured Terascan for performing the scan on the code that gets checked into GitLab. In this particular case, we're going to be pulling down a Terascan image, and then we're going to be basically issuing a scan command into it. As soon as this YAML file, which contains the configuration, gets checked into GitLab, we will see a new pipeline getting triggered. Let's take a look into those. And of course, what we are attempting it, we are also checking in this second deployment file into the main branch. So technically, we should be able to also see more applications running. So currently, there's only one Nginx application running, there should be an Nginx 2 application that should also come up. But first, let's see how the pipeline gets triggered. So we are checking in the code. We've checked in also the GitLab pipeline configuration file, and we are committing it now. We'll punch in our password. The commit happens. We go to GitLab now. We're going to be checking out if there was a new pipeline created. You can see on the screen the YAML file, Terascan has been configured. And if we go to merge request, but to the pipeline, we will see that a new pipeline would have got triggered. There you go. The new pipeline is triggered, and we will see at least one stage there, which is Terascan stage. And if you open it, it is actually failing. And the reason for that is we see that there are multiple issues being detected in the deployment files, right? Including the app armor profile not being set to default. Let's take a look into Terascan, how these things work and how they're looking like. So if I go to Terascan, and if I go to Kubernetes folder under the OPA Rego folders here, under the Kubernetes pod, I see app armor profile.rego file. So if I go to Kubernetes here, if I go to pod, there are a lot of Rego policies here. Rego is a language that is used by OPA for defining the policies. So this is a policy which checks whether you have app armor enabled or not. Now, Terascan has gone ahead and also created templates for Regos so that you can use the same Rego for multiple different policy types if you have different parameters that you want to pass. What we're looking into is right now a JSON file, which is basically invoking the Rego template here. This is the app armor profile Rego template, which has been invoked, which is going to be applied on a resource type called Kubernetes pod. And this is going to check whether you have app armor profile enabled or not. This is what is your policy as code. Now, with this policy as code, what you're able to clearly identify is if such a situation is not mitigated or detected, you want to take certain actions on the GitOps pipeline. So this is how policy as code internally works. Let's go back and take a look further into a demo, how we can now prevent this from happening, or how we can at least make sure that Flux is not doing any kind of sync. So currently, because we checked the code into the main repository, although the pipeline reported that there are security issues, the code is still present in the main repository, we will be able to see that the application is still deployed. And we'll be able to see that in a bit. Let that command finish. In the meanwhile, let's take a look into the next part of the demo. What we're going to do here is we are going to basically do a new feature branch. We are going to check the code into a new feature branch, and we will make sure that we are checking in a vulnerable code. And we're going to raise a merge request to merge this feature branch into the main branch. And we will prevent that from happening so that Flux does not sync up with the vulnerable code. So what we are doing right now is we are just creating a new feature branch, and then we are going to add all this code into the feature branch. So while that is happening, the previous command would have been finished. So we are going to quickly also make sure that we are able to see that Nginx second application, which is Nginx deployment 2, is also synced. So here you can see that this is the previous run that we had. Since we were working on the main branch directly, we were not doing any kind of pull request-based mechanism. Therefore, we were not able to prevent this vulnerable application package to reach through your cluster. But this was for demo purposes. And now let's do this in a pull request manner. Okay, so we've created a new branch. We're gonna just push it. Now, keep in mind, as soon as we're going to push this new branch, it will also have the pipeline configuration. In GitLab, a new scan still will be triggered on this new feature branch. You can see the feature branch has been created, and we will see the results still being showing that there will be violations, policy violations in this new code in the feature branch itself. So if I go to pipeline, we could see it's on the feature branch, and it is saying it is failing because Terascan OPA-based policy as code assessment was performed, and there were issues that have been discovered here, right? That's why the pipeline failed. And now when we will try and create a merge request or a pull request against the main branch, we will not be able to because of the review restrictions that we have put in. And therefore now, if we do the Flux sync, we will not be able to see the Flux sync happening. So even if we create a new branch out here, we will not be able to. So you could see that the merge request would not work against the main branch because there are issues here. So basically in this integration, what we have achieved is we've made sure that bad code does not reach to the sync branches or the sync repositories, which are in connection with Flux. That's one way of making sure that you are only giving good code to Flux. And of course, there could be other ways of integrations as well, where we can have Flux itself determine whether the scan has happened or not, or maybe perform a scan. These are two different strategies. Both have their own pros and cons. So in this demo, we saw today that how we can secure Flux-based GitOps pipeline using OPA-based mechanisms, which are policy as code mechanism. Thank you all for the time today, and enjoy the rest of the conference. Appreciate it.